Welcome to our final video in the series, where we'll be discussing MDE automation using a headless Eclipse IDE, building on what we've seen so far and how we can go forward and apply these techniques to other MDE tools, and discussing the secret world of ants. This video will be a technical dive into some of the details behind the techniques that we've shown so far. As such, we're going to assume that you have some knowledge of MDE and the MDE tools and the Eclipse IDE and Ant-based MDE tools that are available. You understand what Docker images are and how they relate to containers, and how containers can be used within DevOps or CI/CD practices to form automated pipelines. This video will seek to answer some of the more technical questions that you might have, such as how do you do more than the basics that we've demonstrated so far. You may wish to use these techniques with a different MDE tool that is also based on the Eclipse IDE. It may be that you need to author your own custom Docker containers, either to extend the Epsilon example that we've given, or as above, to apply it to a different MDE tool. As discussed in previous videos, MDE and DevOps merging seems to be a logical progression. However, the Eclipse IDE environment is very much GUI, mouse, point and click first. As such, they're not immediately for use in a CI/CD pipeline, which doesn't provide a way for GUI interfaces to be used. Whilst it would be nice if everybody could rewrite their MDE tools such that they could be operated in a headless way within a CI/CD pipeline, that is not necessarily going to be possible. As such, we need to encourage authors of tools to provide such facilities by demonstrating that there is an audience for MDE-DevOps. Therefore, we acknowledge that there is a dependency on GUI components, but with some ingenuity we can work around those limitations to enable current MDE tools to be used in a CI/CD pipeline. This enables MDE tool creators to see the number of MDE practitioners taking up a CI/CD approach, and maybe then consider adding the functionality to their existing tools. Underpinning our approach to automating MDE tasks using a CI/CD pipeline is the Apache Ant. The history of Ant is provided from Wikipedia. Ant has had many nicknames, one of them being another neat tool. The Apache Ant was created when XML was very popular, and as such has an XML style for writing the scripts for building Java programs. Ant build came about as a replacement for the make being a tool that you may be familiar with if you've done C programming. Ant build originally made it trivial to build and test code in the early 2000s. This led to the rise of practices such as test-driven development or extreme programming. Ant predates both Maven and Gradle, and in fact we can see with the Epsilon tool, Ant is the primary implementation technique that's used, and Maven and Gradle are simply offered as wrappers around the Ant processes. The Eclipse IDE was built using Ant to automate its build and management of dependencies. As such, most of the plugins for Eclipse and the Eclipse IDE expose some Ant methods which can be used for automation, and thus Ant is our interface for operating the Eclipse IDE without a GUI environment. So ants are the secret sauce for MDE-DevOps, and the Eclipse IDE is full of ants. So as horrible as it might be to write build XML files in XML, Ant build is how we can use our MDE tools in the Eclipse IDE without using the GUI, and without needing to rewrite all of the MDE tools out there such that they can be operated in a headless way in a CI pipeline. In our previous videos, we demonstrated MDE DevOps using the Epsilon model management toolset. To do this, we used a container which had an installation of the Eclipse IDE and the Epsilon toolset. Our CI pipeline had a sequence of stages, and each stage a number of jobs. And each job could call a build XML file, which would then trigger the execution of an Epsilon program to perform either validation or generation of a model. However, this example was restricted to only being usable with the Epsilon MDE toolset. Similar techniques could be applied to other MDE tools that use the Eclipse IDE and have Ant tasks exposed to perform similar operations, such as the execution of model management tasks. When creating MDE CI pipelines, we might ask the question as to how much Ant build should we be using within this pipeline script. From our experience so far, we've determined that it should be kept to a minimum, and that Ant should be used as a minimal interface layer. Ant build file formats are not like a programming language, and as such it can be difficult to perform certain state or logical controls over the flow of the script. It is easier to do these things externally using a scripting language such as Bash. Thus, we feel it is best to keep the Ant build to a minimum and invoke simple short Ant build scripts that can perform simple tasks that call directly into the Eclipse IDE and invoke a process. Similarly, builders of MDE tools, you should expose as many Ant tasks as necessary for your MDE tool to be operated via Ant tasks. These can then be scripted through build XML files that are invoked using a CI pipeline. MDE toolmakers have likely encountered having the need to make Ant tasks already. However, if they have not, then Ant tasks are something that can be created using Java, and there are guides to help create Ant tasks. One of those guides can be found at ant.apache.org. In the previous video, we looked at several patterns for creating CI automation using Ant build. Our initial demonstration showed a single Ant build file per Epsilon program that needed to be executed. And over several stages in a CI pipeline, multiple build XML files were being called, such that each Ant task that ran correlated to a single job and then back to a single stage. This enabled a one-to-one reporting of errors per job. However, we noted that this would require the management of several build XML files and that they may not be so portable between different projects. As such, then we propose a monolithic build whereby on a CI job name we could have an Ant build switch between the various tasks such that we only need one build XML file that can perform multiple Epsilon tasks by executing various different Epsilon programs. However, this does complicate the Ant build file by now requiring parameters to be passed in and for functions to then switch based on the parameters that have been passed. Our demonstration showed that the model tasks could be aligned to the CI job name, such that a job name would relate to a particular Ant task within the Ant build file. A more complicated monolithic build could organize by the program types that were being executed, and a significant number of parameters could be passed in, which would make the Ant build file further complicated, but would generalize it better, such that now it's possible that a single Ant build can be used to execute Epsilon programs. Depending on your comfort with the Ant build XML style, this may be something that is appealing and you may want to use. However, if you're very uncertain with Ant build and prefer the Ant builds to be kept basic, which makes them considerably more readable, however, not as reusable. While managing many Ant build files may seem an undesirable task, we must remember that the Ant build files will execute many times over within the CI pipeline, compared to the amount of time taken to write them. Through the use of Ant build, we can operate the Eclipse IDE in a headless fashion, such that we don't need the presence of the GUI. Whilst the container that we've got already has the Epsilon environment, the next question will be is how do we go about authoring other containers that contain different MDE tools? Now, when we author containers, we need to think about version control and dependency management in much the same way as we would for software development. And that is to say that things outside of our control may change and our image needs to be recreated. The best solution to this is to author our containers using a CI pipeline. This is done by using Docker files and headless scripts in a GitLab CI pipeline, again, such that we can create new Docker images and load them into a container registry, which we can then use our Docker images from in our CI pipelines for model management. As we've seen in previous videos, we'll be using CI pipelines to automate the process of creating a Docker image. On screen we can see an overview process that is going to be created. Our CI pipeline script will build and test an image that will be placed in the Docker repository for the GitLab project. The Docker image is created using a Docker file as normal. However, to execute the Docker build file, we will be using the Kaneko container, which provides a safer, faster method than a Docker in Docker setup for creating Docker images. In addition to the CI pipeline and Docker file, there will be a series of bash scripts that have been written, which will download the P2 director for installing the Eclipse IDE, and a second script then which will use that director installation to unpack and install the Eclipse IDE and Epsilon. Typically, we would be using the director GUI that is available from the Eclipse website. However, as we're doing this within a container, we need to use a scripted approach which does not use the GUI, hence the bash scripts that have been included. The same scripts can also be used to set up a developer's desktop IDE, thus enabling you to keep parity between the container which will be executing modeling tasks and the developer's or modeler's desktop environment. Finally, we will put a third script into the container which will serve as the entry point script. This will determine what happens when the container is brought online. We've typically overwritten this entry point script when using the CI pipeline, as it is possible to script within the CI YAML file the activities that should be occurring within the container. However, if we wanted to use the container outside of GitLab, then we may be required to have this entry point script such that we can pass in parameters and have the Eclipse IDE Epsilon environment execute Ant tasks. And finally, we'll be using one of the Eclipse Epsilon playground examples as a test to ensure that the container can execute an Epsilon program successfully. So on screen we can see a GitLab project that's been set up to demonstrate how to create the Docker image for an MDE tool using the CI pipeline within GitLab. And we go to VS Code editor space. So our GitLab CI YAML file has two stages. One that will build and deploy to the project's container registry, and a second stage that will perform a test using one of the Epsilon playground examples. So we've added some comments to explain the structure of jobs within the GitLab CI YAML file. And our first job to build the Docker image uses the Canico container. This enables us to build a Docker image within Docker, which is how GitLab operates the CI pipelines. Our jobs are overriding the entry points and providing a script that will be executed within the container within the CI pipeline process. The Canico executor command here is using three environment variables: the Git repository path, the project's CI container registry, and provide a commit tag for the destination. Our test is recalling the image that has just been put into the CI registry. The container is then going to be brought online, and we're going to invoke the entry point script with a build XML and call main, such that we then execute the playground example. If that passes successfully, then we will know our container works. If it fails for any reason, we will know that there's an issue with the build of this container. Docker images are created using Docker files to specify how the container image should be created, and we are using an Eclipse Turmarin image as our base. We're installing a series of packages using the package distribution system of the Turmarin image, which happens to be apt. Having run our apt installation, we clean and remove the apt files, as they will not be required in the image itself. We step to a working directory, being the root of the container, and we copy in and execute some bash scripts. These are in our scripts folder. So our first bash script uses wget to download the P2 director installation system from the Eclipse website. It then unpacks the tar image into a folder. Once we've got the Eclipse director, we can then use that to perform the installation of Eclipse and Epsilon. Now, normally, the director is a GUI application. However, because we're in a CI pipeline, we now need to use command lines to execute the installation. That is done using our second bash script here, which switches to the Eclipse installer directory, sets up two variables, which contain a list of P2 repositories and the installable units, which then list all of the packages that we want installed into our Eclipse IDE. Finally, the installer is invoked, and both of these variables are passed to it, such that we create a large installation command and execute it. Our final destination will be the Epsilon folder off the root of the container, and within here we will find components that we need to execute Epsilon programs. We go back to our Docker file after we've done the installation of the Eclipse IDE and Epsilon. The fourth stage primes the container's entry point such that if we were to use this container outside of the GitLab CI space, there is an entry point script that can be passed some parameters such that you could execute an Ant build file. This is our example entry point script where we list the launcher, a workspace, which is where we will detach our projects. We are using the virtual frame buffer as part of the execution of the Eclipse IDE, such that if any of the components check for the presence of a desktop environment, should detect the presence of the virtual frame buffer and then proceed to load as normal. This is one way in which we ensure we can meet the GUI dependencies for some of the MDE tools that are not designed to be operated in a headless way. We pass in the data, the application, and our build file instructions such that the Ant runner will execute our build XML starting from the given target, which is typically main from the examples that we've shown so far. If for any reason there is an error, then the log file is concatenated to the console and an exit of 1 is given, which will cause the GitLab CI pipeline to return an error for the job, and inspecting the console will show the resulting errors. In closing of the script, we also note that we advertise a volume workspace as the point which we would attach our project folder if we were using this Docker container on a workstation to execute Epsilon programs. Upon committing to the repository, the CI pipeline executes as we would expect. We can inspect the console output generated as a result of our installation script's execution. This is one way in which we can try to debug any errors with the installer. Checking our test job, we can be confident that this container can successfully execute an Epsilon program, as we can see console output from the EOL program that's been executed, and it is reporting successful. If we go to deploy and container registry, we can see our container image has been added, and it is possible to keep multiple versions of your MDE containers. This might be something that you need to do if you have development teams using the container who are locked to a particular version and are not yet ready to proceed to a newer version of the MDE tool. You can create a series of images at different versions and have different CI pipelines using the various versions that are available. To install a different MDE tool, in the second installation script, you would need to adjust the repositories and the installable units such that you install the software components required for the particular MDE tool of interest. While it would be entirely possible to create the containers manually, it makes more sense to deliver the containers using CI pipeline automation. This enables us to respond quickly to the changes that may occur in the Eclipse IDE or with the MDE toolsets that we're using. We want to be able to validate the changes that we're implementing into the containers before we put them into production. The ability to then version our container toolsets enables us to support a wide number of MDE projects from a single GitLab repository that contains the build setup for our MDE toolset. We also gain the additional advantage through scripting the installation routines for our MDE tools that we can consistently set up the developer tool environments for working on our modeling projects, and these must be aligned with the container image, which will be using the same Eclipse IDE and MDE toolset for processing our models in the CI pipeline. So in summary, we've demonstrated how CI automation is possible through the use of a full Eclipse IDE installed within a container environment. The use of containers enables us to place our MDE toolsets into CI pipelines set up to automate the processes that we need to perform on our models during a modeling project. MDE toolmakers are not required to implement command line interfaces for their MDE toolsets. Instead, they have the opportunity to take advantage of the Eclipse IDE's Ant framework that enables CI pipeline authors access to the features of their MDE toolsets. As a CI pipeline author, you're not required to have an in-depth knowledge of Ant build file structures. It is entirely possible to have small build XML files as an interfacing layer between your CI scripts and the Eclipse IDE, which is hosting the MDE toolset that you're using. Furthermore, the CI pipeline skills that we learn to automate our MDE project are the same skills that can then be reapplied to the creation of our Docker images that contain our MDE toolsets. Hopefully this series has been informative and has given you some insights into how we can automate the MDE projects that we work on such that we can deliver ideas to models to products in a much quicker time through the use of CI pipeline automation